Hello and welcome to the Daily Space for today, March 6th, 2019. Where has this year gone? Today we are here to put science in your brains. And I have figured out how to bring back the much requested dog cam without the much rejected noise. So hopefully this will work. We have in the corner of the screen a very sleepy puppy who will wake up the moment any of you donate bits because the Cheerios will fly. Thank you so much to co-host Annie Wilson for coming up with this idea and for all of you for going along with the sport of the dog. Now, the actual reason we are here is science. And today we have a whole variety of stories coming to you from solar systems near and far. Today's first story is one of a very strange artist's rendition. I'm not going to try and explain what is going on with this picture, but I can tell you that this is a picture of Kepler, not a picture, it's an artist's illustration of Kepler 1658. This is the first world that was nominally detected by the Kepler Space Telescope. Now, the reason I say nominally detected is with Kepler, detections are actually just detections of planetary candidates until they can be confirmed with a different kind of telescope. The way Kepler worked is it would observe a star, and as it looked at the star's brightness, it would very, very precisely measure how much light was coming from the star. And astronomers here on Earth, using its data, would look for the decreases in brightness that are indicative of some kind of an object passing between the telescope and the star. These tiny, tiny decreases in brightness are due to, well, planets blocking a small amount of the starlight. Now, decreases in starlight can be caused by a lot of different things. They can be caused by sunspots. They can be caused by just random fluctuations in the amount of brightness coming off the star. And because so many different things can cause the same kinds of dimming that Kepler was sensitive to, we have to look for these planets through a different means. And that different means is looking for their gravitational pull. It turns out that a planet passing near a star will actually pull that star towards the planet and the planet towards the star. It's a mutual kind of yank around. So as the planet goes around, the star actually moves around too. And we can detect those tiny planetary motions, often motions that are the same rate that a human could walk. We can detect those little tiny motions through the changes in color called Doppler shifting of light that are indicative of motion. Just like when you hear a fire truck going by, you can hear the pitch of the sound change as the fire truck comes towards you and then moves away from you. Well, we can also see similar shifts in the wavelength of light. This is the same technique that police officers use to measure how fast your car is going. They measure how light waves reflected off of your car change in color. Well, just like your ear can tell the motion of a fire truck, the police officer can tell the motion of your car, well, astronomers can tell the motion of stars. Now, when this potential planet was first detected 10 years ago, they did a bunch of math. They came up with what they thought was the size of the star, the size of the planet, and they saw nothing there. But it turns out that their initial calculations of that size of the star were completely wrong. And when a graduate student went back and re-measured how big the star should be, she came up with a significantly larger predicted star size. And with that predicted larger star size, a predicted larger planet size. And when they went looking for this new combination, it was there. And now we know that the first planetary candidate ever detected by Kepler 10 years ago. Well, it's actually a planet. So I introduce you to an artist's rendition of Kepler 1658b. Now, this is a super weird world by our limited understanding, because this world is several times bigger than Jupiter, and it's orbiting only a few stellar diameters away from its star. This isn't just a hot Jupiter. This is a Jupiter that is being boiled away. This is the kind of planet that no one predicted. The universe has once again proved itself far more creative than we mere humans are. So, congratulations. This is amazing. So, here's something to leave you to think about. If you were able to, hover in a cloud city on the surface of this hot Jupiter without dying of heat, this sun would appear 60 times larger in your sky than our sun appears in ours. Just imagine that. It would be like 60 dimes spread out and then with all of their friends to make a complete circle that is 60 dimes across in the sky. So, yeah, this is pretty cool. So our next science story is one that's still a little bit weak on the science. In a press release out of the Jet Propulsion Lab, we have a new visualization of what the magnetic field lines in the star-bursting active galaxy M82 would look like. If you look at this graphic, you can see what looks like zebra patterns or hair patterns through the center of this galaxy. These wiggly black lines indicate how the magnetic field lines in this particular galaxy are aligned. You can see that through the center where there are jets coming out of this galaxy, the magnetic field lines are, aligned along the jets, which is exactly what everyone expected to be seen, but now we've seen it. This particular set of detections, thank you, Keeper of Maps. Thank you for the bits. Here you go. Okay. Thank you. This particular galaxy, we knew had a magnetic field. We knew how it was aligned based on other observations. We've now directly detected this, and so we have a press release. So enjoy. Now, my last story for the day is the kind of story I don't often cover, and this is one of an instrument that will be coming to CERN. Now, the reason I don't generally cover this kind of a story is, you shouldn't count your instruments, your telescopes, your spacecraft until they've gotten first light. This is because you never know when funding problems, engineering problems, mechanical problems are going to prevent the science from taking place. But I'm bringing this one up because it's kind of cool, the creative way this team has come up with to build a low-cost, fast-to-assemble instrument to put at the CERN high-energy accelerator out near Geneva. This particular photo is just looking down along the accelerator. Because we haven't built this instrument yet, no photos of it. Now, this instrument that they're going to be building is going to be constructed by the University of California, Irvine, and it's called Phaser with an F, F-A-S-E-R. This is a little bit over a $2 million project, and it's going to be built beside the giant Atlas project, which is so famous for its efforts to help discover the Higgs boson. And for full, proud, bragging disclosure, as an undergraduate, I was one of the myriad of undergraduates. Thank you, Rocket Sage, for hosting. I was one of the myriad of undergraduates who helped weave fiber optics that were used in the Atlas instruments. So my boredom and weaving and probable sweat because it was a summer job, all were part of Atlas, but a very tiny, tiny part. Anyways, so Atlas is where the beams of particles inside the CERN collider come together and lead to high energy particles being created, lead to new particles being created as the beam collides. All of the kinetic energy from this accelerated beam gets transferred into just energy. And that energy freezes out into particles, sometimes new particles. And the particles in this case that are being looked for are the kinds of particles that might make up dark matter. Now, scientists have been looking for WIMPs for a while. These are weakly interacting massive particles. These are trying to be found in large vats of highly interacting material, liquid that is actually similar to the kind of liquid used in dry cleaning. This is a kind of material that reacts with neutrinos and stuff like that. But so far, we're not really succeeding. And we know that you can also see these particles sometimes in particle accelerators, in the cast-offs, in the particles that are flying out of detectors like Atlas. So they're going to build phaser outside of Atlas, relying on the collisions that take place in Atlas, and they're going to be catching the materials that fly through Atlas and into phaser. And what they're hoping to detect is not the weakly interacting massive particles that we've been looking for before. It's instead going to be looking for weakly interacting light particles. So particles that don't have a lot of mass, that might be the final particles coming out of Atlas. So because they're relying on Atlas for the collisions, because they are basically recycling technology that is already being used in other instruments at CERN, they're doing this whole thing for, well, a bit more than 2 million. And that's like free for a high energy collider instrument. So this is just particularly cool. Now, this particular instrument, we won't get to see the results until 2021. And the reason for that is CERN is currently on hiatus. It's in shutdown. They're refurbishing it. They're getting ready to turn the power up to 11, you might say. And this is part of a scheduled regular shutdown. So here's waiting for it to come back online. This instrument will be running from 2021 to 2023, and then the LHC will go back into shutdown. That's the Large Hadron Collider will go back into shutdown from 2024 to 2026, when they're hoping to be able to upgrade phaser to phaser 2, which will be capable of detecting particles at an even wider range of energies. So this is all kind of cool. And I just have to say, go team. So Hanny, this is being done completely buried under the surface. It's kind of awesome. So those are my stories for today. I would like to remind everyone that if you are plotting and planning your summer vacations, you are all invited. It's not free. I'm sorry. You are all invited to join me, Fraser Kane, Skylias, John Matt Gauthier, Paul Matt Sutter, all of us out at Joshua Tree Park, June 26th through the 30th. Out in California, where we are going to be holding an all-stars party out under the dark skies. And this may be the last generation of Joshua trees that Joshua Tree Park is going to have. So I, for one, plan to hug a Joshua tree. So join me. Let's hug a tree together, or you can at least laugh at me. Now, if June in California is not your thing, it's not your only option. We'll also be doing a tour through the American Southwest, departing from Tucson, ending in Las Vegas. And we're going to be touring the telescopes, the geology, the dark skies of the American Southwest. And this is my home country. So come join me and hear the stories of the science, the sights, and all of the amazing history of this part of the land. So hopefully I will see you on one of these trips. And if you checked out the All-Stars party before and went, ooh, that's too expensive, prices have been reduced. So take a look again and see what's possible. And I hope to see you out under the stars. Thank you so much for the bits. She is awake. She is very awake. Here you go. There you go. Okay, more bits for the dogs. So I will now take your questions. Please at me, and I lost the window, so this may take me a moment. One of the side effects of streaming is you always end up with a massive monitor, and the question becomes, where did I put the thing? Oh, some of the Cheerios fell off. I promise the dog will be back. Let's do that. Hi, dog. So here, let's switch screens. And the dog is now under my chair. Let me throw some more bits into the corner to get her back into the corner. Here you go. Stella, come on, go get him. Go. I have a very sleepy puppy today. So looking to see what questions you have. As always, please at me. And while you type those questions in, I'm going to remind you that the Daily Space comes to you most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific, that's 6 p.m. London time. In addition to the Daily Space, we also bring you the Sunday Science Hour, hosted by our own Annie Wilson, who will be hosting this show tomorrow and bringing you a weekly rocket update. Friday morning, in addition to the Daily Space, we are also going to be bringing you, as we always do, a special event as it happens. In this case, that special event is the undocking, re-entry burn, and return to Earth of the crew capsule, the Crew Dragon, built by SpaceX. If this mission is successful, the next test will be an abort test in June, followed by human beings in July. So give us a follow. Follows are free, and we'll let you know whenever we go live to bring you the science as it happens. We are a production of the Planetary Science Institute, working in collaboration with Youngstown State University, and we're part of CosmoQuest, your place to learn and do science. We are here thanks to the generous contributions of people like you, and we are so very grateful for everything that you do, because you make the science possible. Okay, let's see what questions we have. Scrolling. Oh man, you guys were talkative today. Oh, I hit when the mic was muted. Okay, going back down. So I apologize for the mic mute problems. I rebooted my machine and it just didn't pick up my mic driver correctly, but it is now fixed. So the Raven Lillian is asking, what is the name for the method of detection used by Kepler? Kepler uses the transient method, which is where you look for a planet passing in front of a star and identify this occurring by the faint, just a couple of percentage dips in the light coming from the star. So scrolling down. So Larry Weird and Proud says, that galaxy picture was stacked more than one instrument. Yes, the galaxy image that I showed you earlier, and I will bring it back up. I believe is a combination of optical light, radio light, and I believe that it's somewhat illustration and somewhat actual images, and then the the magnetic field measurements that were made using the SOFIA or airplane-borne telescope. So here's exactly what the image caption says. The image combines visible starlight, gray, and a tracing of hydrogen gas, red, observed with the Kitt Peak Observatory, with near-infrared and mid-infrared starlight and dust, yellow, observed by SOFIA and the Spitzer Space Telescope. So this is, yes, many different wavelengths all coming together at once. So returning to the questions, let's see what is next. Hanny's Vorverb asks, will this be done on the surface? This, I believe, was the question that I already answered about where Phaser is going to be. Phaser will be buried underground with the rest of CERN, and it will be next to the Atlas facility. Fenring points out, I've read an article by Dr. Ethan Siegel that concludes that WIMPs are all but excluded as dark matter particles. What are your thoughts on that? And do you have an alternative favorite hypothesis? So I'm very much an observational kind of astronomer. So I don't generally pick favorites among hypotheses, if that's how you pluralize that word. Weakly interacting massive particles that behave, thank you for the sub, Paranor. Weakly interacting massive particles haven't been detected yet, but I don't think we can exclude them completely. I think that we can exclude them from being the dominant form of dark matter if they behave the way they're predicted to behave. But the thing is, we have a very limited understanding that can be observationally confirmed of particle physics. We have a basic, what we call the standard model, that is well confirmed, that has been proven over and over and over again through various experiments. And thank you, Super Cowboy, for the sub. Thank you so much. There you go. With my sleepy puppy happily enjoying all of this. So the standard model, it explains all the observed things. It predicted some of the quarks. It predicted the Higgs boson. The predictions that the standard model made all proved out exactly as predicted. There are other theories, supersymmetry for one, that have made a variety of predictions. And so far, we haven't observed any of the things that were predicted by the other theories. This tells me our other theories don't get us there from here. Thank you, Veronica Cure. Thank you so much. There you go. So given that we don't have any observational evidence for any of the other theories, I don't want to exclude anything. So Ethan's welcome to his opinions. I'm going to wait for observables. And not rule out anything. It does make sense that if weakly interacting massive particles, as predicted, were the dominant form of dark matter, we should have detected them by now. So they're either not dominant, we totally predicted them wrong, or once again, as so often is the case, the universe is just more creative than we are. So let's give it time. What do I think of axions? I am going to choose to have no opinions. I'm only on my first cup of coffee. So Super Cowboy 75 says, could CERN build a particle detector in space? Well, CERN is the name of the facility located on the ground between Switzerland and France near the city of Geneva. So since CERN is the name of a place on the ground, question doesn't quite make sense. Could people build a particle accelerator like CERN in space? Yeah, but there's no reason to. Particle accelerators are perfectly fine on the ground. We don't yet have a reason to put them into space. Gravital wave detectors, reasons to put them in space. Particle accelerators, they're fine on the ground. So, yeah. Okay, so my dog is having a very sleepy day. It happens. Thank you, Rocket Sage. Thank you so much. Here you go. Okay. So Henny's Warverb asks, is Earth Plushie coming back? I don't know. It could be kept at SpaceX as its second passenger. Yeah, I just don't know. It could also be kept on the ISS. I don't know. We will see. We will see. Ripley, Larry asks, will Ripley ride in the in-flight abort test? I don't know if it'll be Ripley or another version of Ripley. I have lots of don't knows today. This is why we do science. It's to learn more things. And there's always so much stuff to learn that it's hard to keep up. So Hanny's Ververb asks, could we have a detector like Atlas CMS in the upper atmosphere? So again, it's happy where it is. And the upper atmosphere is actually problematic because the upper atmosphere is full of high energy particles that would interfere. One of the reasons that we bury things like CERN is dirt helps protect the detectors from space particles. Some things are just better off under the ground. And anonymous gifter, you're a fabulous human. I adore you. Because you are the source of all of these all of these fabulous subs to some of the regulars around here. Thank you, anonymous gifter. The Raven Lillian asks, could the transit method be used on our sun from the Earth or another position within our solar system, like as an experiment or demonstration for a class or something, or would the amount of change in light level be too small to be detected? You can detect the planet Earth if you're in the correct place in the universe to see the Earth pass in front of the sun and you have the right telescopes. When we look at our sun, we are capable of observing Mercury and Venus passing between us and the sun. And this is called a transit, and we do see the total light from the sun dip. I think that there's a Mercury transit coming up in the not too distant future. And there were, of course, two very famous Venus transits back in 2012 and I think 2004 or 5. So yeah, Venus transits, Mercury transits, they're totally a thing. And we can see them occur and measure the light dip. And we know that the planets in our solar system can be seen by folks on other worlds if they're looking and they're advanced and intelligent and they want to look and all that sort of awesomeness. I'd love to have donut holes thrown in front of me, but maybe not at me. That seems like it would get very, very messy. I'm loving all of the subs today, and I know Stella is too. Thank you all so very much. Astro B is asking, why bother building a particle accelerator in space when light speed particles are already there? Exactly. There's no reason to do it. And the particles that are up there already, as I said, they're just going to interfere with what we're trying to do. Bury them. Sometimes you just need to bury a thing. Yeah, Astro B, Venus only transits the sun at very weird intervals. It's 12 and, well, no, it's not 12. It's 8 and something that I don't know how precisely it's repeating at 200, but it is a large interval. So Archie Haddock asks, is the James Webb Space Telescope en route for launch in 2 years? What will it be looking for? I'm just waiting to see when this telescope will launch. JWST is getting periodically re-abbreviated as the Just Waiting Space Telescope. I'm not going to make any promises on when it's going to launch until it has passed all of its tests. When it finally launches, if Congress doesn't cancel it or badness doesn't occur, and there's no worse place for a telescope than on the surface of the planet, because cancellations, accidents, all those things are possible. So when JWST finally makes it to its location beyond the moon, it is capable of seeing the sky in colors of light we can't see here on the surface of the planet, specifically colors of infrared light. This color is particularly good for observing extrasolar planets and for observing the extremely redshifted light that has been traveling to us from the first stars and galaxies that formed in our universe. So this particular telescope has the potential to help us better understand star system formation, planet formation, and the origins of our universe. It just has to get to space first. We will see. We will see. Let's see. What other questions? What other questions? I think I hit the end of the questions, and I did it at about the end of my time. So I'm going to once again thank all of you for being here. Thank you for being part of making everything that we do possible, and for periodically waking up my sleepy puppy by donating bits and making subs and doing all the things that really sustain our scientific efforts. Thank you. You make what we do possible. This has been The Daily Space, right here on CosmoQuest X on Twitch. We come to you most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific, that's 6 p.m. London time. In addition to The Daily Space, we also bring you the Sunday Science Hour, hosted by Annie Wilson, who will also be hosting The Daily Space tomorrow with her weekly rocket update. We also bring you live events as they happen, and one of the ones I can tell you will be happening is the re-entry of the Crew Dragon capsule this Friday morning. That is happening at 7:30 a.m. Eastern. I'm sorry, that is 4:30 a.m. Pacific. We will be bringing it to you along with coffee. So join us Friday morning and catch it all as it happens. We are part of the Planetary Science Institute, working in collaboration with Youngstown State University. The Planetary Science Institute is a 501c3 nonprofit dedicated to exploration of our solar system and, of course, beyond. So thank you all for being here, and wherever in the world you may be, have a fabulous morning, evening, afternoon. And if the weather is willing, get outside and look up. Thanks for being here. Bye-bye.